So if you've wandered in here after lunch and don't know where you are in From Source to Production, the latest in container development. I'm Matt Butcher. I work on the Azure container team. I primarily do open source development. I work a lot with Docker and Kubernetes technologies. My team is responsible for working on projects like Helm and Draft. And this here with me is Brendan Burns. Brendan is, of course, the creator of Kubernetes. He is the director of engineering of Azure containers. So it's really awesome to get to be here today and talk to you guys about the technologies that we are really passionate about. So here's kind of what we're going to do today. The first one is I want to talk a little bit about the container landscape, because I think that Brendan and I believe very strongly that this is the future. However, it's a little different than, it's not really sort of a clean transition from one technology to another. As many of you know from looking at container technologies, a lot of this stuff comes with a whole bunch of new jargon, right? A bunch of new concepts. And some of this can be very frustrating, particularly as we try to on-ramp software developers into this new way of thinking. So I'm going to start out by talking about that problem a little bit, because it is sort of the problem that Brendan and I and our teams are working really hard to try and solve in many different creative ways. And then after we've talked a little bit about that, we're just going to do a bunch of demos. Brendan's going to show off all this cool stuff, both Microsoft-specific technologies that our teams have been working on, but also a number of cool open source tools that we feel are really solving some interesting problems. So just really quickly, by show of hands, how many of you are running, let's say, Kubernetes in production? How about Docker in production? How many of you are interested in maybe in the next 12 months or so feeling like you're really comfortable with this technology? Okay. And how many of you, whenever you hear the term bare metal, want to mentally like substitute, that just means real server? Because that's me. Every time I hear that phrase, I'm like, oh, this was just a server before, and now it's bare metal. Okay, so how I wanted to start out was, I wanted to talk through a kind of history of the cloud technologies that we're dealing with today. And I didn't want to go dates and timestamps and things like that. I wanted to kind of go conceptually and kind of express how it feels to many of us as IT professionals or DevOps or operators or even developers, as we've kind of watched phase after phase of this kind of server technology world, okay? And notice that I started out with bare metal, because when I put real servers there, it just didn't quite feel right. So I'm slowly being acclimated to the new jargon. But some number of years ago, I worked for a large media company. We ran a bunch of very popular websites. And the website that I was responsible for, we ran about 16 actual physical servers as web hosts. And we ran another 6 or 8 as caching servers, and of course we had a giant DB cluster. We were running all of this on bare metal. Every time we talked about having a web server, we meant an instance of our Apache web server stack running on a single operating system, running on a physical server somewhere in our data center. And that was kind of the way of it, right? That's just the way we did business then. Now, for those of us who could afford large data centers, this worked out fairly well in some respects, right? But for those who were startups, small businesses, they couldn't necessarily afford data centers or even a closet full of servers, right? Or leasing the right lines in order to run these things. So up rose this industry that I like to call sort of like the proto-cloud, right? The thing that happened before the cloud. And this was first characterized by things like managed hosting, right? Where you would say, hey, I'd like to lease one of your servers, and here's the operating system I'd like you to install on it. You manage the hardware and some of the basic software stuff, and I'll take on and manage the rest of the stack. So, Rackspace, many companies like that sort of got into this business of managed hosting. Also along came this budget tier, right, for people like me individually, where I wanted to run my blog somewhere. I was running it on a shared host, in which case there was a server somewhere out in my provider's data center that gave me a directory, right? And in that directory, I dumped all of my CMS system and all of that kind of stuff, and it ran. But it was running alongside, I don't even know how many other instances of sites. And I had to use whatever version of Python, whatever version of Ruby, and whatever version of PHP they gave me. because it was really just the same operating system, but we were all segmented off in particular directories. That was kind of like the old way, right? And the first big technology change to me seems to have been the sort of virtual machine layer. My first exposure to virtual machines was probably like many of you, right? I had a MacBook. I wanted to be able to run Windows for a couple of applications, and so I installed Parallels. And so to me, my kind of initial mindset when I was thinking of VMs was, well, this is a way to run another operating system inside of mine so I can get the best of Windows, the best of Mac OS, the best of Linux, and have them all on the same box. But then I discovered that some of my IT admin friends were actually distinguishing the problem differently. They were saying, all right, I've got one big giant 6U server, and I'm running a whole bunch of different VMs on there. One of them's running my Active Directory, one of them's running my IIS server, and they had segmented out their applications among VMs. And I remember thinking, well, that's sort of a peculiar idea, until a year or so later when Amazon got into the game, and several others. And they said, you used to lease servers. Now you can lease VMs from us, right? We'll manage all the physical hardware. You will know pretty much nothing about it. Instead, you'll just upload your machine instances, and you'll be running everything that way. And people really liked this idea because it gave us much of the advantages of having the sort of dedicated system, because we could control all aspects of the operating system. We could install whatever version of Python, PHP, and Ruby we wanted, right? But it was also very, very affordable, fairly easy for us to do. And so the kind of public cloud, the first version of the public cloud came out. Then we had this other technology that was sort of running in parallel. And my read on it is it was never really intended at the very beginning to compete on any level with the sort of VM. So I was at this content management conference in Boston. And it was a fairly good-sized conference, and as anybody who saw me try and get into this room knows, I get lost very easily at conferences because all the rooms look practically the same. So I was running a few minutes late. I rushed into this session on what I thought was content management system taxonomies. Obviously a very exciting topic, but I get in there and there's like nobody there. There are 3 people up in the front and the guy on stage. And I'm like sneaking in, and I get all the way up to the second row, and I sit down right in front of the speaker. And I look up at the slide and I'm like, this is not the right session. This isn't at all what I was planning on going to. Instead of being about content management system taxonomies, it was a guy from Sun, an engineer from Sun, who was really excited about this new technology that they were working on called Solaris Zones. And I'm going, not at all what I'm into. I think I'm going to get up and leave. And then I realized that there are only 3 other people in there. He loses a quarter of his audience if I get up to leave. I felt guilty. I felt awkward. And so I stayed. And that kind of moment sort of changed my perspective on things. But it was sort of the first of 2 perspectival shifts for me. So I listened to him talk, and this is kind of how he pitched containers back then. He was saying, look, you guys right now are developing all together on big Sun workstations where you're all sharing resources. I actually wasn't developing on a big Sun workstation, but I could follow the idea of what he was getting at. And he said, so we've got these container things, these zones, where you set up a container for each developer, and then they can install their own version of PHP or Python or whatever, and they can work in their own little container, and they can suspend their container when they're done for the day, and they can leave, and they can start it back up, and it'll be right where they are. But most importantly, they're not going to be taking away resources for other people or making big decisions that impact everybody. That was the way he pitched it. Not really as a VM substitute or anything like that, but as a development tool that was going to help us accelerate our development. So I was interested, played around with it for a little while, but again, I wasn't a Solaris user, so it kind of drifted from my mind for a little while. A few years later, Docker came around. And Docker made a couple of big design decisions that changed the way that we think about how we run our containers. And I really feel like the way that they pitched it, the way that the LXC and LXD projects pitched it, the way that they explained these things suddenly made this seem like an appealing alternative to a virtual machine and not a nifty little tool for development environments. And the first one that Docker pitched that I think is a really big deal is Docker said, look, a container is a place where you run just one binary, just one application at a time, or one really period, right? And you think about it this way. Here's my application. I'm going to wrap its environment, its file system, all of the important things about the network. I'm going to wrap that around it and package all of that up. And then that becomes the artifact that I move around. Instead of moving the binary around and plugging it into different file systems here and there, we just kind of transport the whole little thing all around. Now that, combined with this idea of containers, all of a sudden it was like, okay, I understand. If I can do that with my application, then that's an awfully sensible little unit for me to take and have developers create those things and then shift them into production. And I think that that's where we started to get into this view of containers as really competitors against the IaaS sort of VM landscape. But containers, you know, I keep holding my hand like a little cup because they are sort of closed off like that, right? And so we needed to sort of invent a new level of technology because some of the things we used to do very easily, like IPC, I open a local socket or I open a pipe and I'm sending data between two processes that way. Doesn't work so well when you're kind of trying to wrap everything up in a little bundle like this. And deploying multiple ones of these and coordinating how they come up and how they go down and how we upgrade them and things like that became a bigger chore. And so out of this landscape comes the container orchestration platforms. And so we see Swarm, Mesos, Kubernetes, and a host of others. So to me, that's kind of where we are right now. We've kind of moved along this spectrum of different technologies, and we've arrived at a place that maybe is a little bit surprising to us in some ways, but is conceptually different, and yet at the same time feels like it's sort of in the lineage of our steps toward virtualization. So of course, anytime we start talking about this, the question comes up, all right, well, what's the difference? Given all you've just said, what's the difference between a container and a VM? And I find that most people immediately dive into the technical answer because that's the easy answer, right? They say, okay, well, when you're running a virtual machine, really you're emulating just the bare facilities of the hardware, and then you run the entire operating system, and compared to containers where you're sharing the kernel. But that's not the important answer to this question. The important answer to this question is more the conceptual difference. What makes working with containers feel qualitatively different than working with VMs? I mean, if they're so similar that we can't tell the difference, we should be able to pick one or the other, right? But we all know that there's something compelling that draws some people toward the container landscape, right? What exactly is that? And I think one way to approach this is to say, well, I said earlier, Docker made a couple of brilliant sort of simplifications and decisions when it came to containers. One of them is that they started building this layered model. So here's the idea. When you're packaging up a VM, right, the way I used to do it was I'd boot up the kind of host I wanted. I'd boot up my Ubuntu system. I would copy my binaries in. I usually used Packer to create an image for me, and then I would push the image up into the image registry and then start an instance of it. But I was dealing with files that were 600 meg to gigs, right? Docker took a different approach. They said, what if we do this in layers? So they said, all right, we've got this concept of a base layer. You've got a starting point. In many cases, this might be something like your bare operating system's libraries, right? libc and a file system in the Linux world, right? And then you take that base and you start layering things on top of it. Okay, I want to install this particular thing, and then I want to install this, and I want to install this. And the way Docker implemented this was as an overlay file system. So I start with a big chunk, and then I just apply diffs over the top. And from the view of the application running at the top of this layer cake, it's just a regular old file system. But when we're composing it by layering on change after change after change, almost in a way kind of like the way version control systems work. And then at the very top of this, we have our runtime of the container. When we actually execute the container, it's got one mutable layer at the top where all the changes are happening. All the other layers beneath it are kind of just snapshots, right? They are immutable. And this particular method of construction actually bubbles all the way up to the Docker file. And so when you're building these things, you are actually building your own layer cake by telling it how you want to construct the layers. So I start by saying, hey, in my from line, this is my base layer. Now, in point of fact, when I call from node 8 here, I'm not getting just one base layer. I'm getting a whole bunch of layers that were piled on to make the node one. But somewhere down at the bottom is actually a base layer that is probably the Debian image or something like that has libc and a couple of libraries. But from my point of view as the developer, I'm pulling that in as my big base chunk, and I'm saying this is the piece I'm going to start building This incidentally will not do anything interesting because I didn't actually bring any of the source code in here, but it's a good example of what we're doing, right? So I import my big blob, and then I say, all right, for layer 1, I want to install the wget program because I don't have it and I need it. So I run that. Layer 2, I want to run yarn install, which is going to grab all my dependencies for my JavaScript app. Layer 3, I'm going to run a yarn build, which is going to convert all my TypeScript into JavaScript. And then whenever this thing actually runs, I want it to run this command. I want it to run yarn start, which will start my web application, my Node.js application. That translates right back to this picture I had before. Okay, my base image is now my from node 8 line. And then each time I add a layer with this run thing, this is what's happening. We're constructing a layer, a layer, a layer, a layer. And when I run Docker build, it's going to build one big representation of all those layers and say, okay, when we grab this thing, we need these layers right here and that base image, and that's how we're going to execute everything. And then when we actually run Docker run, what it's doing is it's taking that topmost layer, the command layer, and that's where everything is really happening. That's the only mutable layer in this entire thing. Okay, so that to me is actually a really big change from the way we were constructing VMs. The second thing we kind of need to talk about here then is how the orchestration system is supposed to work. So now we've figured out how these little Docker containers are useful or are composed each independently. We want to talk a little bit about how we wire them up. So this is sort of the canonical DevOps operator IT kind of view of Kubernetes. And I'm most familiar with Kubernetes, but Swarm and Mesos look roughly the same as far as how they slice up the big pieces, right? So from our point of view, when we're operating these things, we've got some clients, then we've got this control plane, which is responsible for managing all of our stuff. And then we have a data plane where we have some number of nodes. Okay, in Kubernetes land, the node is kind of the particular host instance that knows how to execute Kubernetes workloads, okay? That sounds a little bit vague, so let me try and phrase that a little bit differently. The nodes are the places where workloads can get scheduled, where containers can get scheduled in order to run. Technically, the control plane usually runs on nodes as well, and you can even schedule workloads on your control plane nodes if you want. Not necessarily recommended in most cases. But so we've got these nodes out here, and let's say I'm a client, right? And I'm saying, okay, I would like to launch this container, which is going to be in a pod in Kubernetes. I want to launch this container on somewhere out in the cluster. So this message is going to come through the client to the API server. The API server is going to listen. The API server is going to decode the message and say, all right, I need to schedule a pod. So it's going to pass to the scheduler the description and say, find me a place to schedule this. The scheduler is going to contact the nodes and schedule this particular container to be executed. In some cases, we have other things like controllers that, I don't know, we might talk about those a little bit later today. But we've got this control plane that's basically saying, okay, this is how things are going to run. And then we've got all these nodes, which is basically where the things are actually running. Now, there's something interesting here. I can describe this whole situation. And those of us who come from an operations or IT background are going, okay, I understand. But those of us who are developers look at this and say, but this doesn't, I don't really see how I latch into this. Because the developer's view of Kubernetes looks very different. And this is perhaps like the most salient point here. Developers are going to have to learn sort of a new way of thinking about a lot of these things. Because no longer is the developer's view of how the cluster works necessarily in lockstep with the operational aspects of it. So for the developer, when they're thinking about how they're going to design these applications, they're not thinking about how many hosts they need. They're not thinking about what the low-level operating system is that they're going to have to share, all the libraries and stuff like that, because the container technology takes care of all that stuff for them. They can pick whatever they want to pick. And they're choosing of, a particular version of Debian Linux and Python 3 doesn't impact anybody else out there because they're just defining all of this in a container. So instead, they're thinking, all right, I need a service because I need traffic to get routed in from outside the cluster. And I need to route that to my deployment, which is going to be running all the pods. Each pod is going to be running the application container. And I need to contact a database, which is going to be represented in a stateful set or something like that. So they're talking in a different level of conceptual abstraction than they would be used to. So a way of saying this is instead of talking about running binaries on a host operating system, Basically, we're asking developers now to start talking about how they're going to execute their containers inside of a cluster with a whole different set of abstractions. So in other words, in the past, we've always had to ask developers, all right, you need to focus on how your application is going to run in our production level environment by saying how it's going to interoperate with the file system and how it's going to, what libraries it needs to share with other applications, what parts of the file system it's going to access. We don't ask those questions anymore. Now, the primary object is the cluster, and we're asking them to tell us how their pods need to be deployed. Do they need to be wrapped in a deployment or a stateful set, or all of these new concepts that they never had to talk about before? So here's where we get to sort of the truth of the matter. This new sort of cluster world has a lot to offer developers, but it also is introducing a number of things that are going to be difficult for developers because they've got some new conceptual overload. Overload is probably true, but that was a Freudian slip there. On the plus side, they inherit a whole bunch of new freedoms in this container world, right? Because they can pick the tools that they really want to use for the job. If we've got two applications that need to run in the same cluster, and one needs to run in one version of Windows with one version of Python, and another needs to run in a version of Linux with a different version of Python, we are okay with that. It's really up to the developer to define what they want to use. In some sense, we're giving a much higher degree of ownership to a developer in this case. Another good point here is that we've gotten a little bit closer to parity between our dev environment and our production environment. Because when the developer builds their container, all the files they put there on their little file system that get wrapped up in that container, they're there when it's executed, right? So they have easy access to all those things they expect to be there. A lot of the things we used to have to do by scripting up how we're going to deploy this whole system and get all the files put in the right place and all the permissions, we don't have to deal with that so much. And likewise, the back and forth between the ops team and the developer team is a little bit easier because the developer feels comfortable that they understand the environment that the application was deployed into. The container still looks the same as it did when it left their development box. So we get that parity. And then the third really big advantage that they get is that some of the harder problems that they were stuck helping solve or stuck solving on their own are now easy problems. Okay, a classic case of this is dependency management, where I worked in a situation where my local development workstation was Linux, the production workstation was BSD. And in this particular case, I would install all my dependencies locally, test everything, write all my code. I was sure it was working. I'd package it up, I'd ship it. They'd unpack it, they'd reinstall the dependencies, but they were the BSD dependencies and not the Linux ones, and we'd get all these subtle bugs. And then you would have those really tense interchanges where you're going, hey, it worked on my laptop, and the DevOps guy's going, it always works on your laptop. I mean, seriously, the problem is it doesn't work in production. And you spend all this back and forth time trying to figure out what changed. Well, with containers, a lot of those sort of difficult problems just become fairly easy because, again, we've hit parity, we've got more freedom to choose, and the DevOps team or the operators don't necessarily even have to take an active role in determining what those choices are. But then along with these positives come a couple of big drawbacks, and this is really where we're hoping that the demos that we show today will show how we're trying to get over some of these drawbacks. The first one is the development environment is obviously going to be more complex now, because we have a whole new layer of abstractions that we have to deal with. So whereas I used to have my editor and the particular libraries and runtime and stuff like that I needed for the language I was working in, now I, out of the box, have to add to that Docker configured because I'm running on a Mac. That means I also have to have a virtual machine running there. When I'm doing Kubernetes stuff, I need to have a Kubernetes cluster somewhere that I have access to, whether it's running it in the cloud in ACS or running it locally with something like Minikube. So all of a sudden, my development world has gotten a lot bigger. I have a whole bunch more pieces that I have to keep track of. But the conceptual overhead has also grown quite a bit, because now we have to understand things like what a pod is, what a deployment is, and what a stateful set is, and how to at least explain to somebody this should be run as a deployment and not a stateful set. And these are all fairly new concepts and not ones that easily sort of tack on to other concepts that developers are used to using. And the last one, which may be a little bit surprising, is it's something that used to be kind of a no-brainer for developers is now getting harder, and that's the persistence story. It used to be the case that I could be fairly comfortable saying, okay, well, I can just write files to the file system and then read them back later. But when we're dealing with so many ephemeral systems where the container, when it shuts down, loses that top layer and starts over again the next time I start it, I have to think a little bit harder about where I put files and what I do with them and how I explain to other people where the files are and why. And so in many ways, the life of the developer, there's some good trade-offs, but without exception, it's going to be more difficult in a lot of ways. And I think Brennan and I both really feel strongly that this should not be as big of a burden for the developer. And so for us, for the groups that we work on, the big challenge, the one we talk about every day, is how are we going to increase the effectiveness of developers in this particular landscape? How are we going to streamline it so that they don't have to, on day one, understand all this new stuff? So that things still behave at least in a way that feels comfortable to them, if not, transitionless and all of that. But we want to make it possible for them to run in this kind of container-first world of Docker and Kubernetes in a way that feels comfortable to transition to. So here we want to give you some demos and show off some of the technologies that we feel like are really getting us more in that direction so that we can help developers sort of bootstrap and accelerate their development.
All right, cool. I will log in here. And this is definitely a lot of demos in a row, and so there's going to be, hopefully it'll all work. We'll keep our fingers crossed, or at least you can all feel better about the demos that you give. How many people out there have never had a demo fail on them? There's got to be somebody, right? Sooner or later, someone will come up and be like, I've had demos fail on me all the time, so hopefully this will work. And I will switch on over. I was 8, is that right? Oh, amazing. All right, cool. So Matt did a really great job of talking about how the container has really become the runnable artifact. One of the things that I like to say, one of the models that I have in my head is that a container is really a runnable thingy. Because from the perspective of the cloud and from the perspective of the solutions that you deliver to people as an operator of a cluster, as we do as people who are building these cloud services, that's really how we treat it, right? And that's actually a lot of the power, right? Most of the power of the systems that we have come from being able to sort of have this abstraction where I can have a boundary around something and say, inside of this thing, that's your responsibility. Outside of this thing, that's my responsibility. We'll sort of have our separation of concerns. We can move independently. It really helps empower us. And one of the things I think that Matt kind of alluded to but didn't mention explicitly was that one of the real powers of containers is exactly this decoupling of responsibility and ability to move independently and to iterate independently. But so the question is, well, I have a container. If you are you and you've developed a container, and I'm Azure, what are we going to do for you? And the first place that I think I'm really excited about talking about is Azure Container Instances. So Azure Container Instances launched over the summer. And really, Matt talked a lot about how there are these concepts in Kubernetes, and there's some conceptual overhead. And I think that one of the things that I've found in the cloud, one of the things I've observed in the cloud over time, is that there's some solutions out there that are really great at what I would call 0 to 1 use cases. Right? So if you look at something like functions as a service, Azure Functions, it's incredibly easy to get started. Right? The 0 to 1 is fantastic. The 1 to n becomes more complicated as you build a larger system. You start having many, many functions. It's hard to know how they interact with one another. It becomes a much more complicated landscape. I think in contrast, something like Kubernetes has a lot in the 1 to n case, in the sort of lots of containers category. But in the 0 to 1, it's tricky. And container instances is sort of trying to patch that path. Because right now, and we'll see some other things over time that bridge these gaps as well, but right now it's very hard to go from the world of 0 to 1 to the world of 1 to n. Right? If you have a Azure function, it's very hard to see how you then take that through a container into Kubernetes, although today we'll see a little bit of that. And likewise, it's hard to know, like, how do I tell someone simply, you have this runnable thingy, where do I go? Azure Container Instances is hopefully that thing. And so we'll jump to our first demo. Is that big enough? Can people see that, or do I need to go in bigger? Yes? Okay. All right, cool. ACI. All right, so here we go. I'm going to build a simple Node.js container. There's my JavaScript for my Node application. It's really going to do only one thing. It's going to return hello ignite, unless something bad happens, in which case it'll log something bad happens, but we'll hope that nothing bad happens. It's a little bit redundant, I guess, but here's the Docker file for that. I used an Alpine image, which is a very, very thin image. So one of the great things about these containers is they can be super lightweight. The entirety of this application packaged up, ready to deploy into the cloud, is around 14 megabytes, right? So you can imagine auto-scaling, iterative development, all of these things happen very, very quickly. Contrast that to the world of building this application into a VM image, and you really see where some of the benefits start happening. But so here's my Docker file. I'm going to actually build it. So that's how I build it. It's going to go through a bunch of steps. It was actually quite quick because I've built it before, and so actually Docker caches all of these layers, right? So Matt gave a great explanation of all the layers in the image. Docker actually maintains a cache of all of those images, of all of those different layers. So if it sees something that looks the same as something that it's already built, or in fact, if it deploys an image to a machine that already has that layer present, it won't bother downloading it again. It will share that layer. It's read-only. It'll share it between different applications. All right, so this is ready. Now, one thing that Matt didn't really mention that I think is also a really important part is part of what made Docker successful is that they also introduced this thing called a container registry, a container repository, where you could push these images. Right? And at this point, every cloud, Azure included, has a repository that you can use. And the reason this is important is because in addition to the question of how do I deploy my stuff, one of the questions is just like, okay, I need to get this thing around the world. How do I get this thing around the world, right? How do I figure out if I want to run it in Azure's West data center and Azure's East data center and maybe a European data center and an Asia data center? How do I get my binary to all those places in a reliable way, in a way that I can be sure that it'll all work? And without really thinking about it, and without writing my own custom tooling and all this kind of stuff, right? The container repository solved this problem. So now I've taken my image and I've pushed it up into this repository that I can use. And now I'm going to actually deploy it using ACI. Right? So I'm using the AZ command line. I'm saying container create. There's the image that I just built. Resource group. I'm going to say, please give it a public IP address. And I give it a name, Ignite Node. Right? And so now you can see here, I've gone and I've created my container instance. So right there, and this is live deploying out to Azure Container Instances, I've deployed my container out into the environment. So now we'll try, we figured out where it's going, and we curled it, and there's the server up and running, right? And if you're really good at reading and typing, you too can, from your laptop, go and hit that IP address and see that it says hello ignite, right? So in the span of, I don't even know how long it took, probably most of it was me talking, we've built, pushed out to the world, and deployed to Azure Container Instances a container, right? So you can go from something on your laptop to something running on a public IP address, 20 seconds, right? It's pretty cool. Very excited about that. And at Ignite today, we're also announcing that Windows container support is also coming to Azure Container Instances. So if you're building Windows containers, if you're building Linux containers, if you're mixing them together, doesn't matter. You can use this as a really simple, easy to get started way to run your container instances. That's pretty exciting. All right. So now we're just going to take it back down. Sorry if you were going to go browse to it. And now we've actually deleted that, and we've taken the container down. So something that's really important also to mention about Azure Container Instances is that the billing is by the second, right? And so if you are interested in doing really quick jobs for build or for image processing or for any of these tasks where you need something you want to package up the runnable script that you want to run, maybe it's just even a PowerShell script, right? You want to package up that script into something you can run, and you only want to pay for it for the 15 seconds that it's up and running. Container instances will do that for you. And again, low latency startup, significantly faster than any virtual machine available anywhere in any public cloud. And so I hope that gives you a sense for the simplicity of what you can do with Azure Container Instances and how we can then, but we're going to see sort of how we can then take that image and move forward into orchestration and everything else like that. All right, so that's that demo. All right, so back to my slide deck, if I can remember how do you, anybody know, I always forget how you jump back. Is it Shift F5? Is that how you jump back in at the, anybody a PowerPoint wizard out there? So let's try this. Shift F5. Woohoo! Because if you just go back into the presentation, it goes back to the first slide. It's super annoying. Okay, So I mentioned earlier about this idea of decoupling, and Matt sort of alluded to this. This is what I like to think of as the not my monkey, not my circus line, right? And this is hugely empowering, right? It sort of sounds like, oh, I don't care about that, but actually what it really is an empowering statement about how we can separate our concerns from one another. You don't need to worry about, if you're operating a container cluster, you don't need to worry about the applications that run on top. We've established this contract, and that contract is no longer like, oh, this DLL was installed, or that version of Python isn't that. No, that contract is gone. The contract is, you give me that runnable thingy in a box, and I will run it for you. It's a much more sane contract. It's a much more deliverable contract. It's a much more testable contract, right? Because I can test my own containers against it, make sure that it works, and that way when the developer comes to me and says, hey, it's broken, I can say, no, it's not. Like, look at this green thing that I have. Those are your dependencies, your problems. In fact, this actually happened to me today when someone said, hey, your Azure container instancy thing is broken, and I said, have you checked the logs on your container? And they said, oh, yeah, my C# is throwing exceptions. That's why it's not serving. And so that's fantastic, right? It's fantastic that I can have confidence that my system is working and that the developer can interact with this artifact that's closely tied to their application. So from a developer's perspective, the container API is the not my monkey, not my circus line. I don't care where you got the machines from. I don't care how you're powering them. I don't care anything about anything except for this container-oriented API. But from an operator's perspective, it's the same way, right? It provides the same kind of not my monkey, not my circus about the application. Very, very empowering, I think, to both sides of the equation, right? Because I have this, and this is one of the few talks I gave without this crashed semi-truck slide, but the more we couple our systems together, the harder it is for us to operate, the slower we move, the more frustrating it is, the more we make accidental mistakes, right? So having this separation of concerns is hugely empowering to everybody involved. All right, I want to give everybody a perspective about how easy it is then to create this line. How easy it is to create this not my monkey, not my circus line. Well, if you want to use Azure Container Service to create a Kubernetes cluster, this is what you need to do. You need to create a resource group. Maybe you already have one. You need to create a cluster. And that's the command line you use to create a cluster. And then you need to get the credentials. And the credentials, because the orchestrator puts forth a JSON API, a RESTful API, the credentials give you access to the cluster, right? And this is actually sort of a moment in time. We're working very hard and very close to actually having the cluster be able to consume Azure Active Directory credentials. So in a short period of time, if you bring your own resource group, it's going to be one command to get that container abstraction available to your developers via Azure Container Service. And by the way, available in any region that you want to deploy that into, right? So hopefully that gives you a perspective about how easy Azure Container Services can make providing this cluster API. Because I think one of the other things that happens when people approach this new technology is they think, oh, great, one more layer that I need to worry about, manage, operate, et cetera, et cetera. But the value of having this available as a service in the cloud means actually we're the ones who take on that burden for developers. You're just responsible for ensuring that the cluster is available. And potentially a development cluster, a production cluster, those sorts of decisions need to be made. But really simplifying the task of providing this interface to the outside world. All right, so once you have that container orchestrator available to your developers, let's take a look at what, or even to you, to people as operators, what can we do with that thing? All right, so I'm going to jump out again, go over here. All right. So the first thing I'm going to do is I'm going to create a service. Matt alluded to this. A service is basically a load balancer that serves traffic to a bunch of replicated containers. You can see the YAML for a Kubernetes service here. Basically, it's not that exciting. It says, I'm serving on port 80. It says, I want you to select these particular containers. That's what the selector does. So then I'm going to go and create a namespace. A namespace in Kubernetes is something that allows you to sort of isolate one set of containers from another. Not really from a security perspective, but just sort of from an RBAC, as well as just sort of not stepping on each other's toes perspective. All right, I'm going to deploy v1 of my app. The important thing to notice here is I'm echoing v1 into index.html, so I'm sort of constantly writing v1 into index.html, and then I'm using the Nginx web server to serve that out. So one of the nice things about Kubernetes is it actually allows you to deploy multiple containers as the part of the same group. Actually, Azure Container Instances does this as well. It's called a container group. So you can run multiple containers. Again, this is for decoupling purposes. I can have something that is responsible for synchronizing my website to a file system, and a separate container that's responsible for serving it via a web server, built by separate teams. I may not even build the web server container. That may be delivered by someone else. But they can share a file system, and they can work together to deliver the application. All right, so we're going to deploy this. And you can see the kube control command there. So I've created this deployment. And what this deployment is doing is it's going, and it's actually, if you see here, replicas equals 5, it's going to create 5 replicas of this container out there and serving. All right. So this is, what you can see in the lower left here is that I have v1. The number I want is 5, and the number that are running is 5. And then here you can see I'm hitting that service. I'm hitting the load balancer for that service. And so you can see the host name of the container and then the version that it's serving, v1. So the host name's changing, obviously, as the load balancer sprays traffic between each instance of the deployment. v1 stays constant, of course, because there's only one version of my application. Well, let's change that. Let's see what it's like, actually, to roll out to v2. So I'm actually going to change v1 to v2. And so what you can see over there is I'm starting to do a rollout. v2 is rolling out. What's important to note is even as I hit traffic on my service, I don't see any errors. Right? The load balancer is actually understanding, and Kubernetes understands whether the container is up, available, and healthy. It's only going to bring traffic to applications that are healthy. It gives each application a little bit of time to come down so that it processes any requests that are in flight. And as you can see here, I'm up to having 5 of v2 running, and I'm mostly v2 in my display, and now I'm down to 0. So now v2, I've got those host names rotating through. They're different host names now. And version 2 of my application has rolled out in, I don't know what that was, 15 seconds. I rolled from version 1 to version 2. Now, of course, in reality, you might want to move a little bit more slowly than that, but you guys would be pretty bored if we went, rolled a new replica every 5 minutes, right? But of course, bad things happen. It turns out my boss really doesn't like v2 of the application. He really prefers v1. And so we're going to roll that back. And so I'm just saying rollout undo. And what you're going to see here is a rollback is actually just a rollout in reverse. So you can see v1 replicas starting up again. You can see some v1s mixing in with the load that we're putting on the traffic. Again, no errors in the traffic that we're going. Slowly scaling down v2, scaling up v1. And eventually, we're going to get back to that original starting state where we have 5 replicas of v1 running and 0 replicas of v2 running. And if you look in the load that's on the traffic, still a bunch of v1s and a bunch of host names running through there. All right, so hopefully that gives you a perspective about how adopting this technology, abstracting the container from where it runs, as well as a lot of the infrastructure that Kubernetes can build around that concept in terms of health management, in terms of managing a rollout, all the sorts of things, have really simplified the task of operating a system, right? And one of the things I like to say is that we talk a lot about like how fast can you roll something out? But the truth is, the real question you ought to be asking yourself is how fast can you roll back, right? Because if you can roll back really, really fast, then the cost of having a rollout fail is much cheaper, right? You can take a lot more risks. You can be potentially a lot less careful if a rollback can happen in 10 seconds, right? Than you can if there is no path back, right? I talk to people who say, like, it takes us 3 days of 24/7 to roll out our software, and it's because they have 0 path back. Every single step they take, they're burning the bridge behind them, right? And that's not a safe way to do anything, and there's a reason they move so slowly. It's because of the risk involved in every step that they take. Here, the risk of taking a step is small because it's very, very easy to take a step backwards. It's also worth saying if v2 had started crashing, the rollout would have stopped automatically. v1 would have just continued. Our users wouldn't have noticed a thing, despite the fact that we had attempted to roll out a completely failing service. All right, kill myself through here. Control-C will sooner or later. All right, there we go. All right, go back. Haha, nice. OK, so but that was showing you how you would do this imperatively with the kube control command line, right? I don't know how many people have sort of read or thought a lot about imperative versus declarative configuration. Is that, just out of total curiosity, is that something that means something to anybody? A few people? All right, maybe 50-50. All right, well, so long ago when I started, and I actually did start on the Solaris machine, it was like refrigerator sized and cost more than I got paid for a year, but which is probably why they're no longer with us. you would go in and you SSH in, you want to roll something out, you'd copy a file, jar file, or a binary from one place to another, and that's how you did deployment. That was all imperative configuration, right? And I think we still do a lot of this. Imperative meaning I take little steps, and each one's a command, and I make changes, and I tweak files, and I tweak config files. The downside of imperative configuration is it's hard to have a record of what you did. Right? You don't have anything anywhere that actually tries to say, this is what I want the world to look like. You just have a series of instructions. Even if you turn it into a script, it's a series of instructions. It's not a description of the end state. Whereas with declarative configuration, you say, hey, here's the end state. Here's the goal that I'd like you to be at. You figure out how to get there effectively. And so Terraform is a great example of this. How many people out there anybody use Terraform? People out there, yeah, seems the hands for Terraform. Terraform's an example. Salt is another example. Ansible, the desired state configuration for Windows is another example of this. There's ARM, Azure Resource Manager, which I also work on, is an example of this. It's very powerful to be able to say, hey, system, here's the declarative state. You figure out how to make it work. And fortunately, Terraform works with Azure, it works with Kubernetes, it works with a whole host of all sorts of services. And that's another of its values, is you can mix and match. If your application is partially virtual machines, partially containers, maybe it's hybrid, it's on physical infrastructure, it's on cloud infrastructure, Terraform is a tool that can take you to all of those different places. All right, let's go over here. We'll go. Typo. That's the worst thing that happens. I'm going to be happy. All right, so the first thing I'm going to do here is I'm going to see I have a bunch of namespaces. Remember, again, namespaces are things that sort of isolate different. You can think of them as folders. They're things that isolate different workloads from one another. We showed previously how I could use the kube control command line to imperatively create a namespace. What does this look like instead if we look at Terraform? Well, with Terraform, I have two things. So the first part is this provider, which says, here's the context. Here's the cluster that I want you to deploy to. And then a resource. And in this particular case, it's a namespace. Namespaces are pretty simple, so I'm just going to, that's all there is to it. It only has a name. And so if we do this, we can say Terraform, and I'm going to initialize that directory. I'm going to wait for a second. All right. And then I can say Terraform apply, and it's going to apply that. Right? And so what's happening now is Terraform has looked at the world, looked at my declaration of the way I want the world to be, and it's made changes to the world to make the real world match up to my declaration of the way I wanted the world to operate. And so in particular, if we now look and take a look at the namespaces, we'll see that there's that Terraform demo namespace that has just been created. All right. So that's cool, but not that cool, honestly. So let's actually take a look at a slightly more complicated example. So here, oh, that's too bad. I zoomed in, and so it's off the side of the row. You'll have to trust me, I think, that up above this, there's a declaration of a service, of one of these load balancers. Here I have a declaration of a replication controller. And you'll notice a couple different things. One is that I have this variable substitution here. Right? So one of the things Terraform allows you to do is declare templates and variables. And just like ARM templates or many other templating languages, you can separate out sort of the bulk of what you want to stamp out with a few variables to customize it. Maybe you want to put it into US West and US East and a bunch of other different data centers. That can be a variable, but your definition of your application stays the same. Maybe in production you want to have 10 replicas, but in development you only want to have 1 replica. The number of replicas can be a variable. It's a really nice way to sort of take out the bits that you care about from the shared definition and make sure that there aren't typos between different configurations, that you don't have 10 slightly different scripts for doing rollouts in different regions. It really ensures a degree of consistency. And then the rest of this is a definition of actually exactly the same container that I did before, where I'm actually writing v1 into this index and serving it via Nginx. And so just like before, I can actually do the initialization, and then I can do an application of this. This is much larger because it's a much more complete application. But now that once it's done the application, it's actually gone again to Kubernetes, looked at the difference between the desired state of the world, the actual state of the world, done that application. And now if we take a look at the resource controllers in there, you'll see that I have a web server here. Right, I have a single web server instance running. It's been up for about 17 seconds. And there's the container that implements it. It's now been 27 seconds since it created. And you can see it has 2 ready containers. Those 2 ready containers are the one thing that's writing my files, the HTML to my file system, and the other that's serving it. And there's the load balance service. And so now I can actually fire some load at that, right? And what you'll notice here is there's only one replica, so there's only one host name, right? And what I have open in the window below it is the variables file that feeds into that template, right? And so I have the name, I have the namespace, and importantly here I have the number of replicas. And so I can actually change this number of replicas from being 1 to being, let's say, 4, 3. And I will write that. And now if I apply this, Terraform is actually going to see, and if you see here, there was a whole big long spew before, right? Here, the only thing it says is, look, I updated 1 to 3. Right? So Terraform understands the declared state of the world as well as the current state of the world. It's done a difference between the declared state of the world and the current state of the world. It's noticed that the only difference is that replicas has gone from 1 to 3, and it's applied that difference. Right? And so it says resources. I didn't add any resources. I changed one resource. I didn't destroy any resources. And so now if I look at the number, if I get the containers, I see that there are 3. And if you look at the service that's happening, the load on the service above, you can see 3 different host names are rotating through there. So I hope that gives you, in one case we showed you how deployments can be used for successful rollouts. I think bringing Terraform in shows how you can now suddenly go, instead of managing it with people on a command line, you can take these Terraform state files, place them into version control. You can use all of the best practices around version management in terms of code review, in terms of even unit testing to ensure that your application deploys correctly. And then you can use this tool to instantiate this declarative config out into the world. All right. And of course, I can actually delete things too, right? And so when I've said here, I want you to actually go and destroy this thing. And it says, are you sure? Do you really, really want to do this? And I'm going to say yes. And so at this point, it's actually going in and it's tearing down that namespace. And namespaces are kind of like resource groups. Once I tear down a namespace, I tear down everything that is part of that namespace as well. So all of the containers, all of the load balancers, everything is getting torn down. It's a nice convenience. It takes a bit of time to do that, so I'm going to switch off out of there and go back to my slides. And we'll move forward. All right. So that hopefully gives you an idea about sort of what you can do with the orchestrator and what your developers can do with an orchestrator. I think one of the most fascinating things that's actually happening is that we're actually starting to see what happens when you build on top of orchestration. Right? And so container orchestration is now a commodity, I would say. It's available in all of the major public clouds. It's something you can just sort of turn on and start using as part of your application. And so if this thing has become a commodity and we just expect that it's available, what are the things that we're going to start building? And so what I think is most interesting is we're starting to see some of these higher level developer-oriented services starting to be rebuilt as tools that live on top of container orchestration. So whereas something like functions as a service might mean you have to deploy a system that controlled a whole collection of machines just to have functions as a service, we are now seeing functions as a service being deployed as a tool that runs on top of your container orchestrator alongside other containers deployed by other people in other environments, right? It means that the choice of a particular platform, again, is a much more flexible choice. You don't have to have your entire company buy into one platform as a service. Developers can kind of pick and choose different kinds of platform as a service for the particular application needs that they have. Or people as operators can say, actually, we're going to deploy functions as a service and others across our container orchestration system, and we won't have to care that it turns out people want more functions as a service. How do we scale that up? Well, it doesn't matter because all we do is scale our container orchestrator layer. We don't really worry about scaling up, the big data part or the functions as a service part or the, data plane serving. They all sort of mix around on the same container API. All right, so let's take a look at what functions as a service looks like. Let's get over here. All right, so I'm going to be using a system called Kubeless. There is a variety of different functions as a service platforms that are out there that run on top of Kubernetes. Kubeless is one of them. So I'm going to create that namespace again folder to hold my stuff. One of the things people are starting to do is you can curl something from the internet, deploy it straight into your cluster. Again, all of the standard warnings about maybe not downloading random binaries off the internet apply. But you can see what has happened here actually is it's deployed a stateful set running Kafka. It's deployed a Zookeeper stateful set. It's deployed a controller. It's deployed a bunch of load balancers. And it's deployed this really interesting thing here called a third-party resource. So one of the things that Kubernetes has that is part of it is not only does it have the API objects that are defined as part of the core, but it actually has the ability for people to dynamically add new API objects to it. And so in fact, and the value of this really is that all of the same RBAC, all of the same user permissions, all of that stuff still applies to these new objects that have been added. And so in fact, what this functions as a service has done is it has created a bunch of infrastructure to run itself, Kafka and all this sort of stuff, but it has also created a new API object to represent the functions that you might want to run. And so if you see this, I have no functions, right? Before I created that third-party resource, if I tried to execute that command, it would have said, I don't know what functions are, right? So I've actually created, in Kubernetes, I've created a malleable cloud. I've created a cloud that I can walk up to, and I can create my own API objects, or I can have third parties who are also creating API objects. It's pretty cool. At least I think it is. So here's a very simple Python function, functions as a service kind of style. All it does is, well, it logs the message that it got in, and then it says hello. It returns a message that says hello to this person. All right. So now I'm going to use the kubeless command line, and I'm actually going to deploy this into a Python 2.7 runtime. And in the background here, it's gone out. It's created one of those third-party objects. The infrastructure has noticed that it's created a third-party object. It's deployed that piece of code that I had on my machine. It's actually wrapped it up in a container, but you don't see that because it's happening behind the scenes. And now at this point, I can actually say, OK, let me see my functions. Now, I didn't have any functions before, but now I have this get Python function that I just defined. And then I can actually go and hit it. Here I'm going to make a call. I'm going to pass in name ignite demo. This is my data package in. And then you can see the message out saying hello to the ignite demo, right? So in that little section there, I've taken a little piece of Python, simple function handler. I've deployed it into a functions as a service running on top of a container orchestrator like Azure Container Service. I have then made a function call to it. Again, simplifying the developer's experience. They can just focus on writing that piece of Python code. And then, of course, obviously, I can interact with it the same way. I can delete it. And then, of course, I can tear down that namespace. It's going to take down everything that was part of that. All right. So hopefully, that gives you an idea of that. I should do a quick time check, I guess, also. Yeah, I got 10 minutes, 15 minutes. All right. So the next piece that I want to talk about, that gives you an idea about how some of these developer platforms can be deployed and managed on top of a system, a container orchestrator like Kubernetes. The next piece that I wanted to talk about was what I really think is the future, right? So functions as a service, kind of well understood. Deploying it on top of container orchestration, maybe that's new, but it doesn't really change things that much. But there are these concepts that are starting to percolate out that I think are really going to fundamentally change the way that we build and deploy systems. And in particular, and they sort of dovetail in with these third-party resources and a few other things. But in particular, it's this pattern here that I showed, which is I'm going to actually, we used to think about installing daemons or startup services on machines. What we're starting to see now is people are starting to think of deploying daemons or startup services onto clusters, right? Matt pointed out really, really eloquently that we're shifting from the developer thinking about managing a machine or code on a host to managing a cluster and containers being orchestrated by a cluster. The same thing is true for sort of this ancillary services that provide capabilities to that developer. And I'm going to give two examples of this, right? So the general pattern for this is I have some sort of daemon running. The user walks up to that daemon with some sort of intent, and then the daemon makes some sort of managed service happen, right? And so for the first example of this, I want to show you this idea of an operator. So the idea behind an operator, it was coined by the folks at CoreOS. They the idea is you can take the knowledge of someone who knows how to run a server really well, knows how to run a database, or knows how to run on any other kind of workload. You can encode it in a piece of code. That piece of code can actually run on your cluster itself. And then your users can actually just walk up to that piece of code and say, hey, I'd like a new database. And the operator is then responsible for all those steps that would have been manual before. The operator is responsible for instantiating all those things and then managing those things. So we're going to actually look at this system called etcd. It's a reliable key value store, also by CoreOS. And we'll take a look at a demo of what that looks like to deploy. So all right. So here's the etcd operator.yaml. You're going to notice two different things. One is that it has this deployment, and another is that it has a namespace. So again, I'm going to create this namespace. It's a folder that takes care of all my stuff. I'm going to create a deployment. Now, what's interesting about this deployment and this particular container that I'm deploying is that this container actually then looks back at the Kubernetes API server and instantiates another one of these third-party resources. Right? So by the act of deploying this container into my cluster has actually modified my cluster to add new capabilities and to add new APIs. Kind of like adding a new driver into your operating system. All right. So I've created it now. It's up and running in my cluster. And so you can see here, there's the container that's up and running. It takes a few seconds for the container to get up and running and healthy, so I'll stall. And we'll hope that it's back up. No, it's not there yet. It's probably pulling the image would be my guess. And the trouble with me having built this elaborate scripting interface around how I run my demos so I don't have typos is that I only get one shot at each command. But if it goes south, and we'll fix it. All right, so here's an example of the cluster definition. So this looks like one of these Kubernetes API objects. But the API object is, in fact, actually a custom one that has been created specifically for managing clusters. And in this particular one, I'm going to say, oh, I want the size of my cluster to be 5. Right? I want to have 5 replicas of my key value store communicating with one another. So we'll create that. Ooh, it was there. So we stalled long enough. So now I've created an instance of an etcd cluster. Right? So I've extended my cluster. My cluster used to know about containers and groups of containers and load balancers to containers. My cluster now knows about etcd, it knows about databases as an object. Right? And so my users can walk up and they can just create databases, not worry about what's going on behind the scenes. And so now, oh dear. Now what are we going to do? I'm going to have to look at my script. See what the problem is. Let's see if we can do this. I'm going to have to. This is the trick of having not run through all of them at the same time. I have a separate session already created. All right. Whoa, what? That's not cool. You knew it had to happen sooner or later, right? It would have been too good. It would have been too good if it made it through. Let's try this. Comment out all this other stuff here. This is like, this is what shows you that it's actually real. Or maybe not. I don't know. It is actually. But there's this but I hate having typos, and so I'd like to. All right, there we go. So what you can see here is I have my etcd operator running, and I have my 5 replicas of etcd running. In fact, I can say, I'm going to exec in there, and I'm going to actually show the cluster health. And so what you can see here is this is actually talking to the database. They're all clustered together. It's actually printing out the fact that it has those 5 replicas and that the cluster is healthy. And so now I'm actually going to go to that cluster definition, and I'm actually going to scale it down. I'm going to scale it down to 3 replicas. And what you're going to see here is after I change the state, it's actually reconfigured it. And what you'll see over in the display there is as it starts as the operator sees that I've asked it to be scaled down to 3, it's starting to terminate the containers. Right? It's actually scaling down it's actually scaling down the database to have 3 replicas instead of 5 replicas, all through that declarative configuration. Again, this might have been a series of imperative steps that we took previously, where we deleted a machine or we deleted a process, took things down. Here, I'm moving to a declarative representation, not just for the containers that I want to run, but for the applications themselves that I want to deploy into this cluster, right? And so now, actually, if I go and I do the same thing and look at the database cluster that I'm running, oh, it deleted 0. I'll have to do this again. Yes, well, I know that that's not going to work, but all right, well, it deleted it. But if it had a 1 there, you would have seen that the 3 replicas are there. And now, actually, I deleted the cluster. It's actually taken them all down. So again, we're moving from managing our infrastructure imperatively to managing our infrastructure declaratively, from managing our applications to even managing the data systems that run on top. All right, and got 5 minutes left. Kill this. Jump back. I want to do one other demo. OK. The next one is the same pattern, but in this particular case, it's one that uses this program called kubelego. How many people have heard of Let's Encrypt? Most, 2/3. Let's Encrypt is basically a service that allows you to get SSL certs using an API. It's super cool. If you haven't checked it out, you should check it out. Everybody should be using HTTPS for everything, and Let's Encrypt makes it super easy to do so. But it could be even easier. And the way that the kubelego daemon actually makes this even easier is this thing sits in your cluster. You can declare as part of Kubernetes these things called ingress that are basically HTTP load balancers. Instead of the previous services that were all TCP, these are balancers at the layer 7 HTTP level. What the kubelego daemon allows you to do is you can actually, oh, I said etcd cluster definition, that's a typo. What the kubelego daemon allows you to do is you can actually say, I want an SSL cert to be applied to this HTTP load balancer. That's my declaration of state. No longer do I go to some website or go to some administrator or anything else like that to get a valid SSL cert. I just assert that I want this thing to have one, and magic, it happens, right? And so to show this, we will drop out. All right, we'll hope that this works. OK, so Matt sort of mentioned briefly, he works on this project called Helm, created this project called Helm. Helm is a package manager for Kubernetes. So you can think of it like apt or like chocolatey or like nougat-ish. I don't know if nougat's the right analogy, but chocolatey is definitely the right analogy. It's a way of representing an application and installing it with a tool, right? And unlike using one of the other previous tools, which installed things onto a single machine, this again installs it onto a cluster. We're moving from the host to the cluster. And in particular, here's the variables, the parameters that I can send to the Let's Encrypt chart. There's sort of this nautical theme to Docker started with a whale, and it just sort of escalated from there. There's just marine imagery all over the place. But these are charts. And so what I can say here is this is how I want to deploy this kubelego daemon. And then I can actually just say, well, I'm going to show you. When I try and talk to demos.azurecontainers.io, curl says, hey, no, cert bad. That's not good. And so instead, what I'm going to do is I'm going to take that chart. Here's the configurations for that chart. I'm going to install it onto my cluster. So that's Helm, knowing how to install kubelego. And then it gives me some instructions. And in particular, so Helm gives me some, hey, you've installed this thing. Here's how you might want to do it. In particular, what it says is, if you say kubernetes.io/TLS-acme true, if you add that to your HTTP load balancer, as well as having a valid host name down here, suddenly that cert is going to get applied to that load balancer, right? And so here is the definition of this ingress resource, this load balancer. And you can see here I have, hey, I want to use TLS. And hey, here's demos.azurecontainers.io. And we're going to apply that. And so it actually reconfigured this load balancer. Now, the daemon that I installed is noticing that that load balancer is asking for a cert. It's going to notice that no such cert exists. And now what you're going to see here is I'm going to be doing repeated curls. So in the background, hopefully, the system is going and it's allocating a certificate And it's going to attach that certificate to the load balancer here. And we're going to keep our fingers crossed that it actually works. In a second, you should see the pure HTTPS instead of this invalid cert, hopefully. Keep my fingers crossed. It's not frozen. Still waiting. All right. Well, in the meantime, while we wait for this, and we'll keep our fingers crossed this going, I'm going to conclude. Does anybody have any questions? I have a question. Yes, please. Can you use the microphone, by the way, because we're streaming. It helps with the people.
All right, thank you. Yeah, so can you quickly go over the value of using Terraform in place of just using manifest files? Is there...
What sort of manifest? Oh, you mean like Kubernetes manifest files?
Exactly.
Yeah, so unfortunately it got clipped, the fact that you could put two things together. There's two major differences. One is Terraform has this built-in notion of variables, and Kubernetes and kubectl by themselves don't really know about templating. So if you want to say, hey, I have this simplified variables file with 3 values, and people tweak with that, and I tweak with the main template, Terraform will take care of that for you. It also has a really nice way of combining multiple resources. So you might say, I want a load balancer and a replicated thing and a database, and it allows you to sort of staple them all into one file. There are ways to do that in Kubernetes, but it's uglier. And also, if you wanted to cross-reference between them, use the same value in multiple places, that's trickier too. So,
okay.
Yeah.
Thank you.
Yeah, no problem. So I'm betting that something went wrong with my Kube Lego demo. So. But we'll keep it there just in case, you never know. Anything else? Yes?
This is probably obvious, but I'm assuming that you could scale out replicas for your function as a service as well?
Yeah, it takes care of that for you, right?
Okay.
It puts an autoscaler on it.
Okay.
Because functions as a service, that's kind of its...
That's what I was figuring.
That's its thing, right?
Okay, cool.
Yeah. Anything else? So sad. I could debug. We could live debug why this thing isn't working.
What mechanism do you recommend for building Docker containers with things like DB connection strings?
Yeah, so there's kind of two different approaches. Kubernetes has built-in secrets. And so you can use those secrets. You can also use something like Key Vault, Azure Key Vault, and then use a secret to bootstrap access to the Key Vault. One of the most interesting areas that is still being sorted out is how we can actually give strong MSI-based, I don't know if MSI people have heard of it, it's managed system identities. Anyway, it's an identity that Azure will manage for you. Get those into the container so you don't even have to bootstrap. The container, by running in Azure Container Services, would just have a token that it knows how to use to go talk to Key Vault and go from there. So there are good solutions now. There will be better solutions in months. Yeah.
One more question, just on mapping services to external DNS providers. Do you support the external DNS incubator project? Is there a better way to do it?
It should be there. I know someone was working on it. It should be there so that you can automatically use Azure DNS with it. If not,
it works. I just wondering if that's the best way to achieve that, you think?
It's a decent way to do it. There are other ways. It kind of depends on who manages your DNS entries and stuff like that, I guess is what I would say. So, yeah.
Yeah, I think we're out of time here, but if you want to talk,
we'll hang out.
Yeah, we'll hang out here. We'll be in the exhibit. I'll be in the exhibit hall on and off over the next few days. Also, several of our colleagues who also work on this are around. Thank you all very much.
Thank you so much. Thank you.
Thank you.